Hello everyone, my name is Erwin Dela Cruz, and today I will be presenting the hazard analysis of the University of New England's machine shop worksite. The UNE machine shop facility is located at Biddeford, Maine, and has about 15 full-time employees at the worksite that consists of 90% male and 10% female. The age ranges from 30 to 65 years old, and most have high school education and some with college education. The employees at the UNE machine shop facility work from 6 a.m. to 3 p.m. and are given an hour break at lunch and two 15-minute breaks. The employees also spend most of the day working on university vehicles that include cars that are usually up on lifts performing general vehicle maintenance, such as changing fluids and changing tires. The UNE machine shop facility does not have a formal safety committee on campus, and there have been no OSHA visits at the facility. The incidence rate for injury on auto dealers in the state of Maine is at 5.3 per 200,000 hours worked. The experience modification rate at UNE was above 1, but in the last 5 years has lowered to 0.75. And over the past 5 years, there have been 3 back injuries that have resulted in 10 lost days. During the evaluation of the safety and risk factors that were potentially present within the worksite, the hazard analysis consisted of various sections that included a tour of the facility and an in-person survey of 2 office employees. The initial findings include physical hazard exposures of high noise levels that were measured to be between 80 to 90 decibel range with tool usage, high rates of repetitive motion including awkward postures, and heavy lifting of 10-ply tires that can weigh between 50 to 75 pounds. Chemical exposure from vehicle maintenance or repair was also observed that includes fluid changes, etc. The identified hazard analysis of the machine shop worksite included repeated impact and high hand force that includes gripping of unsupported objects comparable to clamping light-duty automotive jumper cables onto a battery, etc. Using the hand, heel base of palm, and vibrations with the use of tools such as an air hammer from tire changing, awkward movements or postures such as working with hands positioned above the head or shoulders for long periods of time, heavy lifting from tire changing, working with the neck bent more than 45 degrees without support, and working with the back bent forward more than 30 degrees without support. Other hazards at the worksite include physical and chemical exposures, such as high noise from the use of automotive tools, low light levels, and processing with chemicals such as brake fluids, use of lacquer thinner, and such, respectively. During the hazard analysis, the demand control model, developed about 30 to 40 years ago by Dr. Karasek and Dr. Theorel, was used to illustrate the relationship between workplace stress and psychosocial job demand. To accomplish this, a series of questions were asked of the employees using a standard scale of strongly agree to strongly disagree. Each question answered was given a numerical scale rating from strongly agree at 4, agree at 3, disagree at 2, strongly disagree at 1, with no measurements of neutral on this job content questionnaire, or JCQ. These numbers were then entered into the demand control model for analysis. To demonstrate our finding, 2 employees of the UNE machine shop were assessed for the job content questionnaire, or JCQ, to assess the psychosocial stress at the worksite. These are the calculated results of the job content questionnaire, or JCQ algorithm, for each employees 1 and 2. As you can see, Table 1 show the results of Employee 1's JCQ interview algorithm, illustrating a skill discretion at 34, which is about 85% compared to the national average at 40, a decision authority at 40, which is much greater compared to the national average at 35, a decision latitude of 74, which is about 98.7% compared to the national average at 75, and a psychological job demand result at 32, which is equal to the national average at 32. Now, Table 2, on the other hand, show the results of Employee 2's JCQ interview algorithm illustrating a skill discretion at 36, which is about 90% compared to the national average at 40, a decision authority at 48, which is much greater compared to the national average at 35, a decision latitude of 84, which is much greater compared to the national average at 75, and a psychological job demand result at 32, which is equal to the national average at 32. Now, the psychosocial stress factor results from each conducted interviews were calculated, measured, and classified according to whether the worksite experiences high or low stress levels among its workers, according to the demand control model. According to the demand control model, as you can see, Employee 1 from the UNE machine shop facility passively learns with an average stress level compared with the national average. Employee 2, on the other hand, seems to be actively learning and experiences an average stress level compared to the national average. If you go back to Employee 1's demand control model, the national average was decision latitude of 75 for the national average and a psychological job demand average of 32. The employee, on the other hand, has equal amount of psychological job demand at 32, like the national average as mentioned earlier, and the decision latitude at 74, which is slightly lower than the national average score. Employee 2, on the other hand, has the same psychological job demand as the national average at 32 and a decision latitude at 84, which is much higher. However, the difference between Employee 1 and Employee 2's assessment is that Employee 2 has more of an active learning compared to Employee 1. Going back to interpreting both results of the demand control model for both employees as far as comparing them to the national average. As mentioned, Employee 1 from the UNE machine shop facility passively learns, since it's lower than the national average, at 74 compared to 75 of decision latitude, and an average stress level compared with the national average, the same at 32. Employee 2, on the other hand, also seems to be actively learning and experiences also an average stress level compared to the national average. Therefore, we can also conclude that the employees assessed reveals an average stress level with improved decision-making skills and authority. To maintain and further improve on the prevention of occupational hazards at the UNE machine shop facility at Biddeford, Maine, employers at the worksite can develop and provide an on-site health and safety committee on campus. Having an on-site occupational safety and health administration, or OSHA, visit and monitoring accident incidences can actually help with this endeavor. Allowing time to further improve on job decision-making skills, minimize accidents or hazards that occur the most at the worksite, provide consultation programs to identify, control, and eliminate work hazards, possibly install PPE at all workstations where multitasking is conducted. These include safety glasses, face masks, steel-capped footwear, gloves, helmets, and overalls, etc. Possibly setting up safety signs around all workstations to promote a safe environment. And employers could maybe encourage staff to report unsafe practices to supervisors. Now, examples of corrective actions by employees can include volunteering to be in the Health and Safety Committee, reporting hazards and any injuries to the management as soon as possible, regardless of the intensity of the injury, and of course, allowing or encouraging colleagues to maintain a safe environment and practicing good safety skills. That concludes our hazard analysis of the UNE machine shop facility in Biddeford, Maine. I hope everybody has a good day, and if there's any questions, just simply ask. Thank you very much.